Hello, my name is Isabella and I will be your host for another mathematics video brought to you by RJ. My question for you today is, does 10 have a friend? Everyone needs a friend. This video was motivated by the same question in a video made by Numberphile. If you haven't seen it, the link is in the description. By definition, two natural numbers are friends if, for one number, the ratio of the sum of its factors to itself is equal to the same ratio of the other. We can write this as A over B is the ratio, n is the number in question, and this summation is the sum of all the factors of n. We can actually rewrite the summation in terms of factors. F sub I are all the factors of n, and Blackboard F sub n is the set of all factors of n. Factors are nice, but is there something else that's better we can work with? Yes. Every number has a prime factorization, and since there's some prime that divides each factor except one, which we will get to in a minute, and each factor divides n, then there's some prime that divides n. So we can write this in terms of prime numbers.
Prime numbers. Prime numbers. Prime numbers!
P sub I are all the primes in the prime factorization of n, and Blackboard P sub n is the set of all primes in the prime factorization of n. There's an issue here. The sum of all primes may not always be equal the sum of all factors. Why? Because the sum of primes just accounts for each prime individually, not a product of primes. In other words, there may be factors that equal a product of primes. So, we could be missing terms on the right. Can we fix this? Absolutely. We need a function that produces a polynomial where the terms are every possible product of the primes. This can be done with a product of geometric series for each distinct prime. I say distinct because there may be factors with multiple of the same prime in its product. The number of times each prime occurs in the prime factorization of n is called that prime's order. Now, suppose we have a list of distinct primes and a separate list containing the orders for the corresponding distinct primes, which we will call each B sub I. We have our function, which is suitably called the function for producing elementary anti-symmetric polynomials. This is very similar to the function for producing elementary symmetric polynomials. The only difference is that this function counts each term with the same value in the polynomial only once. Now we have the sum of factors is equal to tau. We can now substitute this into our ratio formula. A over B equals tau over n. Before, I mentioned that there's some prime that divides each factor, except for one. This is true. However, tau accounts for a term where the power of all primes is 0, which equals 1. Thus, this formula still holds true. Now that we have a nice formula for friends, let's look at the number 10. Our ratio is 9/5, which means A equals 9 and B equals 5. This implies that any friend of 10 must be a multiple of 5. And since 5 is prime, that friend has a 5 as one of its primes. Furthermore, the sum of that friend's factors must be a multiple of 9. We know 5 cannot be a friend because the sum of its factors is 6. which is not a multiple of 9. So we need to look at numbers with more primes. Let's look at an interesting consequence of tau. Suppose we rearrange these terms so that all the ones containing a p sub 1 are listed first. Now, let's factor out a p sub 1 from all the terms we listed first. We notice what we have inside the parentheses is exactly the same as what we have in the second line. Let's denote this as tau prime, and we can shorten this as we can see, tau can be represented by a product of itself without a particular prime and one more than that prime. Therefore, if we know a particular prime, as we do in the case of 10, then we can write Q is n divided by p sub 1. The last term in tau prime is actually Q itself, so we can subtract that term from both sides. Remember, Q is a product of primes, and since we have a 2 here, then 2 must be another prime, p sub 2. If we let Q equal 2 times r, then we have a problem here. The last term in tau double prime is r, and all the other terms in tau double prime are positive, meaning r cannot equal tau double prime. Tau double prime is greater than r, therefore there are no more primes. The only 2 primes n can have are 5 and 2. Obviously, their product is 10, thus 10 has no friends. Would you be 10's friend? I challenge you to find friends of other natural numbers. Thank you, Numberphile, for inspiring this video. Thank you, Nicole de Boer, who played Leaven, a math genius in the thriller Cube, for the exclusive clip. I hope you enjoyed the video. Thank you for watching.